Okay, so I'm going to go through now the 2017 4E5N Prelim Science Chemistry paper. So let's look at question 1. The table below shows information about 5 particles A, B, C, D, and E. Letters A, B, C, D are not actual symbols of the particles, so these are not elements. Okay, these are not a symbol of the elements. So what you see is over here you got atomic mass, mass number, number of protons, electrons, and neutrons. So this is a question actually on atomic structure. Okay, this is actually a question on atomic structure. So first one, it says complete the table above. So you know that atomic number is the same as the proton number. So let's settle the proton number first. Okay, so atomic number 2, proton number 2, 3, 3, 7, 7. For D here, we don't know the proton number. We don't know atomic number, but we know the number of protons is 12. So this must be 12. Okay, then atomic number 16, proton number 6, then number of protons 16. Mass number is actually the sum of the proton and neutrons, because the mass is actually the proton plus the neutrons itself. So this is 4 equals 2 plus 2, correct? 7 equals to 3 plus 4. What is over here? 7 plus 7, so you got 14. Okay, and that's all left. Okay, now next one. The last one we have actually is number of electrons. Okay, number of electrons over here. So if you look at particle A, okay, the atomic number is 2, the proton number is 2, the number of electrons most probably will also be 2. Okay, because we just assume, this is one of the assumptions that we are making, is that the particle A, the number of protons equals to the number of electrons. Now, so you say, how do you confirm? Maybe lesser electron, more electrons is possible. But actually, we look at it, periodic table, atomic number 2, this is actually the particle helium. So if this is helium, it actually will not undergo any bonding. So it will not lose, gain, or even share electrons. Therefore, the number of electrons that atomic number 2, particle with atomic number 2 will actually have, confirmed, it will be 2 electrons. Okay, so this is the starting part. Let's go next question. Okay, next one, which letters A, B, C, D, E represents the particles that react oxygen to form acidic oxide? What we have is C and E. Okay, why C and E? Actually, the simplest way to go about doing this question is to identify what elements they are based on the atomic number. So B, okay, atomic number 3 is actually lithium. Now, to be exact, because it lost 1 electron, this is actually lithium plus. C, atomic number 7, okay, this is actually nitrogen. D, atomic number 12, this is magnesium. E, atomic number 16 is actually sulfur. Okay, so which particles react with oxygen to form acidic oxides or acidic oxides, right? Okay, what you're gonna have is C and E. Why? Because nitrogen and sulfur, these two will actually form what we call acidic oxide because they are non-metal oxides. Okay, so when you want to look out for acidic oxides, you must look out for non-metals, non-metal oxides. Okay, so therefore it is C and E over here. Which particles are which particle, so just singular, is chemically unreactive? As I mentioned just now, is A, okay, because it's helium. So this one, let's write helium over here. Which particles are from period 2? So this one, I need to look at a periodic table. So if you look at periodic table, actually the only answer is B and C, because lithium and nitrogen are both from period 2, the second row. Okay, row 2. Next one. Which two particles react to form an ionic compound in a ratio of 1:1? So I need ionic compound, means I need metal plus a non-metal. Okay, ratio 1:1. So I need both to have the valency, same valency lah. Okay, valency is actually the number above the group number. So if you look at our periodic table, okay, so above the group number, there's actually 1, 2, 3, 4, 3, 2, 1, 0. All these numbers here are considered the valency. So when you're doing chemical bonding, when you want to find out what's the chemical formula, you need to look at the valency. So sulfur is 2, sulfur is over 2, sulfur is 2. Magnesium, if you look at it, magnesium also 2. So because both valency are the same, so therefore the two particles will actually be D and E. Okay, D and E, magnesium and sulfur. Okay, so take note of that. Next, question 2. Okay, question 2 states ethanol was reacted with hot potassium manganate 7. So this is actually oxidation of ethanol, oxidation of alcohol. So what you're going to get when you react such a way, you're going to get carboxylic acid. So to be more carboxylic acid, to be more precise, if I use ethanol, I'm going to get ethanoic acid. Okay, so part A. Suggest why electric heater is used to heat this reaction instead of a Bunsen burner. So the key idea here is prevent fire. It's actually more of a safety thing. Okay, controlled heating. Okay, now why control heating so that we don't have naked flame? The key idea here is also because ethanol is flammable. Now we are going to reject control temperature because this electric heater doesn't control temperature at all. Okay, so therefore that's why we will reject control temperature, but we will allow for all these other answers. Part B, what's the purpose of the condenser? Okay, so this is actually more of like a separation technique kind of question. What really you use a condenser for? So it's to cool the vapor. Okay, so to cool the vapor, if you ask me, what I would suggest is to cool the vapor and allow it to condense. Okay, I would prefer if you have these two answers together. Okay, so the key idea for condenser is to cool the vapor and allow it to condense. Okay, name substance X. So if you look at substance X over here, it's a result of the reaction. So when, as I mentioned, ethanol, when you have potassium manganate 7, the resulting substance X over here is actually your ethanoic acid. It's actually your ethanoic acid. And last one is actually still one observation that can be made. This is actually on your redox part. So if you use potassium manganate 7, what you're going to observe is that the purple solution will actually turn colorless. Right, the purple solution will actually turn colorless. So all this, okay, are the answers here. So this one under your redox. So do take note. Okay, you can revisit your redox if you need some additional help. Let's go to question 3. Question 3, the diagram below represents a molecule of carbon dioxide. Once you look at this molecule, you should be able to identify this will be the carbon, this is the oxygen. These two lines here is actually double bond. Okay, so from the diagram above, is it an element, compound, mixture? This is quite a giveaway. It's a compound because it is consisting of two elements chemically combined together. So with a bond is chemically combined. Deduce the number of shared electrons in a molecule of carbon dioxide. So I need to know the number of shared electrons. We need to know that whenever you see one bond, it's actually one cross one dot. So if I got 4 lines over here, one cross one dot it means 2 electrons. So if I got 4 lines over here, that's why it is 8 electrons. Next, draw the dot and cross diagram to show the bonding in carbon dioxide. Draw only the outer electron shells. Do take note of this. Okay, sometimes they didn't say draw only the outer electron shells. Hence, you must draw every single one. Okay, but for now, they only ask for outer electron shells. So therefore, this is how the diagram would look. Take note, correct number of shared electrons. So we are looking out for the overlapping region here, which you have cross dot, cross dot. Overlapping region here, cross dot, cross dot. Okay, so that's one mark. That's where it will go. The second one is unshared electrons. Carbon should have no unshared electrons. Oxygen should have 4 for each of them. 1, 2, 3, 4. 1, 2, 3, 4. So another one mark here. Okay, next. Let's go on. Substance with chemical bond found in carbon dioxide normally have relatively low boiling point. Okay, so actually the key question here they're asking you, how come covalent substance? How come covalent substance have relatively low melting boiling point? So first thing, okay, we want to see is that is it made of small molecules, or you can write the word simple molecules. Next thing, okay, it has weak intermolecular force of attraction. Forces of attraction. Okay. Then lastly, it requires little heat to overcome. My suggestion, don't any two lah. You should include all these 3 in your answers. Okay. Next, let's go on to the next question. Question 4. So question 4, reaction between metal and acids are redox reactions. Which reactant in the above reaction is the oxidizing agent? Okay, give a reason for your answer. So there are many ways to look at this. Okay, my suggestion would be you can either go by the oxidation state way, or you can think in terms of the electrons gain / loss way. Right? So there's oxidation state way, there's the electrons gain / loss way. Whichever you're more comfortable in. Okay, but in this case here, okay, so they gave both answer. So which is the oxidizing agent? Answer is H+. or you can give hydrogen ions. Why is it so? Because the H plus actually, you can see here, the H plus actually accepts electrons or takes electrons from the magnesium atom. Okay, so if it takes electrons from the magnesium atom, means that it's actually oxidizing the magnesium atom. So it takes electrons from magnesium atom, means that it has oxidized magnesium. If it has oxidized magnesium, okay, therefore it's an oxidizing agent. Or the other way is you just need to say that the oxidation state of H decreases from +1 to 0 in H2. This means that H is reduced. Okay, the substance that's reduced would also normally be known as the oxidizing agent. Okay, so just take note of that. So this part here, okay, do recap a little bit, especially when it comes to your redox part. Okay, because maybe some of you have a bit lost touch with it, yeah? Okay, let's go next one. So next one will be the rate of reaction between the metal and acid can be investigated using the above, using the apparatus shown below. So this is your setup. So magnesium ribbon hydrochloric acid, the gas collected here, okay, because it's acid plus metal, you know it's hydrogen gas. So they give you that, 0.6 gram of magnesium was added to 50 cm3 of hydrochloric acid. The concentration is 2.0 mol per dm cube. Acid was in excess. Okay, so there's excess acid, excess acid, which means that magnesium is the limiting reagent. Okay, so the hydrogen evolved was collected and the volume was measured every minute. So every minute, measure. The results are plotted and labeled in graph 1. This is now repeated with 50 cm of hydrochloric acid, so same amount of same volume, but the concentration is higher. Okay, concentration is higher. So the results were then shown. So now the question is, why is graph 2 different from graph 1? Okay, so first thing, you need to know the difference, which we already mentioned is the concentration. Therefore, at higher concentration in graph 2, so we have identified the key difference is that the graph 2 has higher concentration of sulfuric acid. Of hydrochloric acid. So if I have higher concentration of hydrochloric acid, let's do the explanation now. Higher concentration means more reactant particles per unit volume. Okay, means that the collision becomes more frequent, which means that the frequency of effective collision increase, so the speed of reaction increases. Okay, and really the key idea that marks the difference is that it has a steeper gradient. Okay, so you can see it's quite demanding for this one mark over here. There's really all these things to write. So my take is, so how many marks would I get if that is a question not to be asked here. I think the key idea here is to make sure that you have included all the points that you need for part 1. So all these points that I've underlined here, do make sure you have it. If you don't have it, include it in. Okay, make sure that you're aware of what is happening. Let's go next. Okay, the first experiment was repeated using sulfuric acid instead of hydrochloric acid. Describe and explain how the graph will be different from graph 1. So what's the difference between sulfuric acid and hydrochloric? So sulfuric acid is H2SO4, hydrochloric acid is HCl. What's the difference between them is that one of this will give me 2 H plus, okay, and 1 SO4 2 minus. This guy here will give me 1 H plus only plus SO4 2 minus. Now the strength of the acid really depends on how much H plus is released. So if I have the same concentration, that means imagine I got 1 H2SO4, 1 HCl, same concentration, okay, I know that, right, even though there's only 1 H2SO4, there's only 1 HCl, the amount of H plus that comes out from H2SO4 will be doubled of that of HCl. Okay, so what I'm going to expect in terms of it is just think of it as the concentration of H plus has increased. So it will look similar to graph 2. So B part 2, what I'm going to say is that we will expect a steeper line or a higher gradient or increased rate. Any one of this. Okay, increased rate of reaction. Why is it so? It's really because sulfuric acid produces 2 mole of H plus ions for every 1 mole of acid. Okay, compared to 1 mole of H plus ions for 1 mole of H plus ions or 1 mole of acid for HCl. Okay, so take note of that. Okay, Next one, part 3. Calculate the volume of hydrogen gas produced at room temperature and pressure. Okay, now you need to take note is that the volume of hydrogen gas produced is dependent on the limiting reagent. So if you look at it, all the question that we had so far, I said, should I use the volume of HCl? Should I use the volume of sulfuric acid? Which one should I be using? It's not clear. In actual fact, whether you change sulfuric acid, you change hydrochloric acid, the amount of hydrogen gas produced is actually the same because the limiting reagent did not change at all. Okay, the amount of limiting reagent did not change at all. So what does it mean? It means that in terms of the Mg, okay, Mg will be the main one that we're going to be using to determine the volume of hydrogen gas produced. So how to calculate the volume? First, we need to find the number of moles of Mg. So we take 0.6, which is the mass given here, so 0.6. Okay, divided by 24. Now this 24 here is not the volume of gas. Actually, the first one that we're looking at is this triangle over here. Mass, mole, mR. So you take the mass divided by the mR, you found the number of moles. Ratio, okay, how do you know the ratio here? It's actually, you must know that Mg, okay, you can actually use HCl, or you can use Mg, or you can use H2SO4, whichever the case is, but I'm just going to write the equation out for you. Okay, MgSO4 plus H2. So you realize that by writing the equation, the ratio is 1:1, 1:1, regardless of whether I use hydrochloric acid or sulfuric acid. So therefore, the mole ratio 1:1. So the second step, once you determine the mole ratio, hence the number of mole, H2, more H2, okay, produced, not required. It's actually equals to 0.025 because you take this multiplied by 1/1, you get 0.025. Now to find the volume of H2, what you're actually doing is just taking the mole. So this one here, the triangle that you're using is actually mole, 24, and then volume of gas. So take the mole, which is 0.025, multiplied by 24 dm cube, you actually will get 0.6 dm cube. So this one here, okay, is the third step. Okay, so 1, 2, 3, these are 3 main steps. If you actually want to be more precise, it's 1, 2, 3, and 4. 4 steps in total that you need to get your marks. Okay, next. This one, everybody's favorite. Okay, whenever you have such a diagram, most people will be thinking, am I getting how to go about doing it? Okay, key idea here. Always whenever you see such a diagram, okay, ask yourself, what is the question testing for? So some of the things you definitely would know. Whenever you see the barium nitrate, this is actually a test for sulfate. Okay, test for sulfate. Okay, let's write the word sulfate. Test for sulfate. Sulfate. Silver nitrate, test for chloride. Aqueous ammonia, this is actually a test for cation. Sodium hydroxide, once again, this is also a test for cation. Now, okay, what else do you see? Okay, you don't really see anything else, right? So now, if you do a test for chloride, what observation? If there is a okay, so there's actually, you look at it, they say solid F is a mixture of 2 cations and 1 anion. 1 anion. So observation M, you do not know yet. But what you know is that, if I add barium nitrate, I got white precipitate here. So if this is a white precipitate, I know this will be barium sulfate. If this is barium sulfate, which means my solution M actually contains something sulfate. The sulfate is confirmed present here because there's a positive test for sulfate. Now, in the question it says solid F is a mixture of salts containing 2 cations and 1 anion. So if it already contains sulfate, would there be chloride? No, there will be no chloride over here. So the observation M here will be no visible change. Or you can write here no observable change. Okay, so that one is settled. Next one, add sodium hydroxide. Oh, this one I know lah, that's for cation, right? So light blue precipitate. What is this guy here? It's actually copper 2 hydroxide. Now, where got heat one? How come heat got produce ammonia gas? So you think about it, because it says it has 2 cations. So copper 2 hydroxide is the first. Copper 2 is the first cation that I'm going to have. Right? Copper 2 is the first cation I'm going to have. The second cation that I'm going to have, in order for me to do a test for cation and produce ammonia gas, it means that my solution here must contain what I know as the ammonium cation. Okay, so go and look through back at your salts. If you add sodium hydroxide and you warm it and ammonia gas is produced, you will know that actually this tells you that the NH4 plus ion is present, okay, in the salt. Whenever you see such a result, it tells you that the main solution must contain ammonium cation. Okay, so these are some of the things that we have obtained so far. Next one, add aqueous ammonia, light blue precipitate J. You can see these two are the same. So this is actually your copper 2 hydroxide. Last one over that we have here. Okay, you heat strongly, you get pungent gas G. This pungent gas G, in your syllabus, there's only one alkaline gas. Can you see pH 10? There's only one alkaline gas that you know is actually ammonia. Last one, we got white solid F. Dissolve in water, you get solution H. Actually, this one, white solid F, is a mixture, right? These two things are actually the same thing. It's just that this one is a solid version. This one is a solution version. Okay, so what we have inside solution H and white solid F is actually copper 2 sulfate and ammonium sulfate. Okay, so name substance G. G we already talk about it. It's ammonia. Okay, actually it's here lah. Ammonia gas. J mentioned copper 2 hydroxide. L barium sulfate. What are the 2 cations present? Most of you would have gotten the Cu2+, but the ammonium cation is the one that most of you are missing. So take note, ammonium is present. And last one, using the information given, predict observation M. As mentioned, there's only one anion present, and you already know there's sulfate present. Therefore, there is no chloride present. So the test for chloride will be a negative test. Okay, negative test. As such, your observation will be no visible reaction. Okay, no observable change, no precipitate, or no visible change. Now, we will not accept there's no observation. This kind of thing, please do not write in your practical. So, okay, no observation, there is observation, we'll add them, the volume increase, all this kind of thing. Okay, the key idea here is there's no real change in terms of color, no precipitate that's formed. So just take note of that. Now let's go on to question 6. Okay, halogens are a group of non-metals in group 7. So very nice, they already tell you what halogens are. The reactivity of halogens decreases down the group. Okay. So describe an experiment which shows that chlorine is more reactive than iodine. Now, how to show this kind of thing? Actually, we are looking at the idea of having a displacement reaction. So what you can do is you can add chlorine to potassium iodide or to sodium iodide or to any iodide solution. Okay, the key here is why we put this in bracket is really because you can replace this with sodium or whatsoever as long as it's a solution. So add chlorine to your potassium iodide solution. What's going to happen is that you're going to see the iodide being displaced. That's why your solution will actually turn brown. A brown solution is formed. Okay. Now, what's the equation that we're going to see here? What you're going to write, most of you will actually be writing this, or if you use sodium, it will look like this. It's literally just replacing the K with the I. Okay, so 2NaCl plus I2. Okay, so the ionic equation, I doubt most of you will be writing this. You all will be either writing the chemical equation, okay, and most of you will be thinking on terms of the observation. So please take note of this. Okay, please take note of this. A brown solution is formed. So I'm circling brown. Add chlorine to potassium iodide or sodium iodide or whatsoever. So these are the 3 main points you will need to have. Okay, B part 1. Okay, so once again back to mole calculation again. Calculate number of moles of sodium hydroxide used. So what's the question? Chlorine reacts with cold dilute sodium hydroxide in the following reaction to produce sodium chlorate. Okay, look weird, don't know what the crap that is, but never mind. They give you the equation. With the equation, you can definitely do the question. So this is chlorate. It is chlorate. Huh? First question says calculate the number of moles of sodium hydroxide used. So they give you the volume, they give you the concentration, how to find mole. So the triangle that we actually will be utilizing is actually concentration, okay, mole, volume. So to find the number of moles, I actually take the concentration. Actually, okay, I will rewrite this. Let me rewrite this a little bit. Let me write this a little bit. I'll rather write 0.5, okay, multiplied by 500 divided by 1000. Now 0.5 is the concentration. 500 over 1000 is actually the volume in dm cube. Can you see this is in cm cube, this is in dm cube. So I need to convert this into dm cube. So to convert this, I need to divide it by 1000 to convert it to dm cube. Okay, so therefore, if I take 0.5 multiplied by 500 over 1000, I'm going to get 0.25 mole. Okay, so that's the first part. Calculate the mass of sodium chlorate produced. So since I got a mole of sodium hydroxide, next I need to find the number of moles of sodium chlorate. So based on the equation, I know that 2 sodium hydroxide will produce 1 sodium chlorate. So I'll take 0.25, that's the mole of sodium hydroxide, divided by 2. So this number of moles of sodium chlorate produced. Next, to find the mass, I will need to take the mole multiplied by the MR to find the mass. So therefore, I find that MR of sodium chlorate, which is 23, is for sodium, 35.5 for chlorine, oxygen 16, you get 74.5. So if you take 0.125 multiplied by 74.5, you get 9.31. Okay, now do take note, the final answer should generally always live in 3SF. Okay, this is a bit different from math. For science, generally most of the answers is either 2 or 3SF. For chemistry, just stick to 3SF. Okay, so let's go on to the next question. Question 7. Okay, an organic compound is grouped into homologous series. State 3 general properties of members belonging to the same homologous series. So this one, just copy and paste from a textbook. Okay, so take note of that. Next, ethanol belongs to one of the homologous series. Name the homologous series and the structural formula of ethanol. So ethanol is actually belonging to the alcohol homologous series. The structural formula is this. Okay, so do take note. All single bonds, 2 carbons only, and you should have the OH here. So you say, why am I OH right at different places? Can it be on the left hand side? Answer is yes. Okay, it can be on the left hand side, it can be on the top, anywhere. Just key idea here is each carbon should have 4 bonds only. The O should be attached to the H and C on the other side. If you're not sure if your diagram is correct, check in with your teacher. Okay, take a snapshot, check in with your teacher. Next, ethanol can be produced by fermentation in the lab. The temperature of the mixture should be kept around 37 degrees Celsius. So 37 degrees, okay, good. Why the temperature is kept around 37 degrees Celsius? Giving reasons, give another precaution to take. So there's 2 things you need to do. Explain why, giving the reasons, and also plus having another precaution to come in. So if the temperature is raised above 37 degrees, what is happening is that the yeast will actually produce enzymes. These enzymes will be denatured and fermentation will stop. Or you use, okay, so take note of that. Okay, so the enzymes will not function, okay, and fermentation will stop. This is the reason why you shouldn't let it go above 37. What is the other few things that you need to take note of is that the rubber bunk should be secured tightly. Okay, or the other one is the lime water in the test tube prevents air from entering. Okay, so you realize the solution is here. Why must we have the lime water here? Actually, you can put water here also. The key idea here is you don't want air to flow in. You take the rubber bunk, put here. You put the lime water here. It's actually prevent air from going in. Why? Because fermentation can only take place in the absence of air/oxygen. Okay, to be more precise, actually the absence of oxygen. Okay, why is it so? It's because once you have oxygen in, the bacteria will oxidize the ethanol to ethanoic acid. Okay, so once again for this one here, you want to know how the marks are allocated. Am I correct or wrong? My suggestion is don't ask this question. just make sure that you got all the points included. Okay, so the more whole your answer is, okay, the less you have to worry about when the question changes. Okay, you're able to answer, twist and turn in any pattern that you need. Last one. Okay, for this part here, another method of obtaining ethanol is by reacting ethene with steam as shown. Okay, reacting ethene with steam as shown. The yield or concentration using this method is close to 100%. Okay, close to 100%. State one advantage and disadvantage of using ethanol, producing ethanol using fermentation over reacting ethene with steam. So advantage is any one of these here. So when you use fermentation, actually you use less energy. Why? You can see it's 300 degrees, it's 60 atmospheric pressure. So you need to change the condition, and these are actually using quite a lot of energy. Whereas fermentation is normal condition. Okay, 37 degrees Celsius, generally in warm weather, stuff like this. Normal air pressure also. Next. Okay, then addition of steam requires a special pump as the pressure is higher. Okay, it is actually more expensive. So more expensive, okay, can be used because atmospheric pressure versus higher pressure. Higher pressure versus atmospheric pressure. So the key idea is less energy for fermentation. Okay, less expensive or more expensive, whichever the thing is. Just need to make sure you adjust accordingly. So advantage of using fermentation is that it uses less energy. When you talk about in terms of another advantage, it could be that it is less expensive using fermentation. What's one disadvantage? Definitely you can see here is about the yield. What is the yield? Is that the final product. So if you remember, if you do fermentation, the max is about 15% alcohol. Okay, you're gonna get 15% concentration of alcohol. Okay, whereas for this, you're gonna get close to 100%. So the yield or the concentration is actually lower for the fermentation process compared to using steam. The other one is obviously when you do such high temperature, high pressure, the speed of reaction obviously will be much faster. Okay, for this compared to fermentation. So do take note of the two disadvantages and the two advantages over here. I do know that the phrasing is a little bit inconsistent. So make sure that when you write down your answer, consistently talk about advantage of using fermentation, disadvantage of using fermentation as the main thing. Okay, so I'm going to stop here. This is the end of section A. The video for section B will be recorded in another one. Okay, so that's all from me.